My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 472. In this lecture, we will try to understand k-means algorithm. So, now let's look at Lloyd's algorithm, which is how we compute or we find k centroids C1, C2, so on, Ck, which we need to determine. These k centroids need to determine for k means. So let's go step by step. The first step is called initialization. The initialization step, in the initialization step, we randomly pick, because we are given a data set of endpoints d equal to x1, x2, xn. We randomly pick k points. Yes, we randomly pick k points because we want to find k centroids. Pick k points from data set D and call them our centroids C1, C2, so on, Ck. This is called random initialization. The first step is to initialize the points. Each of these points xi, let me say, each of these points xi belongs to Rd. Rd means what? It is d-dimensional vector. Rd means, isn't it? Just say this one. Xi belongs to Rd, d-dimensional vector. What is your I? I is varying from 1 to n, means your x1 belongs to Rd, x2 belongs to Rd, so on, xn belongs to, all the points are d-dimensional points. Centroids are also, centroid is also d-dimensional point. Centroids are also d-dimensional points. The first step is called initialization. The second step is called, what is my second step? It is assignment. In the assignment stage, in the initialization stage, we initialized our k centroids with some random values. There are other initializations which we will discuss later in this chapter. This is called random initialization. So in the assignment step, what we will do is this: for each point xi in your data set D. What is my data set D? My data set D is x1, x2, so on, xn, isn't it? For each point xi in your data set D, select the nearest centroid Cj from set of centroids. How many centroids are there? There are k centroids, C1, C2, so on, Ck. Select the nearest centroid Cj from the set of centroids nearest to xi, isn't it? For this, what would you do? You would compute distance between xi and Cj for all j equal to 1 to k. What does it mean? How many centroids we have? I am checking for data point xi. For example, if I keep I equal to 1, I am checking distance between this x1 and Cj, means if I keep Cj, j equal to 1 means C1, j equal to 2 means C2, so on, j equal to k means Ck. I am checking the distance between the x1 and C1, x1 and C2, so on, xk and Ck. I will repeat this for all other points x2 to xn, isn't it? We will find smallest distance. Let's assume Cj is the, by finding the distances, let's assume Cj is the nearest centroid. Let's assume my Cj is the nearest centroid to the point xi. Then you will add the point, xi to set Sj. Why? Because Sj is the set. This Sj is the set corresponding to centroid Cj. Simple. Let me assume Cj is the nearest centroid to point xi. Then you will add point xi to Sj, because Sj is the set corresponding to centroid Cj. You will add your point add your point xi. You will add your point xi. This is a loop. I can say this is a loop. For each point xi, I must repeat for x1, x2, so on xn, and I have to determine distance between xi to cj, isn't it? This is a loop. For each point xi, you will find the nearest centroid, because you already have centroids here. In the initialization state, you pick some random points as centroids. You assign each of these points. Each of these points means xi. This is called as an assignment stage, because you assign each of the points to the nearest centroids, and you add to set sj corresponding to the centroid cj. This is called assignment stage. The third stage is called recompute. Actually, the third stage, here in step 2, what we are doing, for each xi, you are finding nearest centroid and identifying corresponding set sj, and you are adding this xi to sj. That's what we are saying, isn't it? For xi equal to 110 and j equal to 1 to k. Now, what it says that this is called the third stage is called recompute the centroid stage. At the end of stage 2 or step 2, what do you have? You have each, at the end of step 2, you have each point xi assigned to set xj. Each point at the end of this particular step 2, each point xi is assigned to sj. How you are assigning? You are finding nearest centroid and keeping in corresponding set, isn't it? This is what you have. This is what you have at the end of step 2, isn't it? Each point xi is assigned to set sj, and you have j equal to 1 to k, and I is going from 1 to n, isn't it? Now, in recompute centroid, this is step 3. What you will do is this: you will recalculate this. This is also called update stage. Actually, this stage, there is another name for this stage is not only recompute, update stage. You recalculate or update your centroid. Recalculate or recompute or update your centroid. You update your CJs. Which one you are updating here? You are updating CJ, isn't it? How will you update? In initial stage 1, you have your random centroids. Now you update your centroids. How can I update it? There is a formula: Cj equal to 1 by mod x mod sj. What it is? Mod sj sigma xi belongs to sj sigma xi. What does it mean? C1 means centroid corresponding to set S1. What is this? Mod S1. If I keep j equal to 1, what is this? Xi belongs to S1 and this xi. What does it mean? Just what you are doing here. This is mod S1 means number of elements, size, number of elements, and you are taking xi belongs to S1. You are taking all the points in set S1 and adding them. You are dividing with number of points. This mod S1 is number of points in S1. Mod Sj means number of points in Sj. The size of set Sj, isn't it? So, what happens at the end of stage 2 or step 2? Each of your points are assigned to set Sj. Now you will take each of these sets. This is like computing average. This is like computing mean point. This is like computing mean data point or the centroid point, I can say. This is also called centroid because you are trying to compute average point. You will update each Cj. For each Cj, take all the points belongs to Sj. For each Cj, take all the points that belongs to Sj. For each Cj, there is corresponding. For each Cj, there is corresponding Sj. Take all the points that are there in Sj, and what you have to do after taking all those points, isn't it? This Cj is mean point or central point. Yes, now I am calculating Cj equal to mod Sj sigma xi belongs to Sj, sigma xi. What is this mod Sj? This mod Sj is number of points in set Sj. So you get, now what will you get? You will get new Cj now. Now you will get new Cj, isn't it? Now you will get new Cj, isn't it? New Cj. Yes, so you will get new Cj. You update for, you are updating for C1, C2, so on, Ck. This is called updating or recomputing your centroids. Now, step 4. What is this step 4? What does it mean? What does it mean? Step 4 is repeat. Now, step 4 is you repeat step 2 and step 3 until converges. This algorithm is also an iterative algorithm. So, we had initialization stage, isn't it? In step 2, what is step 2? Step 2 is assignment stage, isn't it? This is also iterative algorithm. So we had initialization state which is not repeated. You repeat your assignment stage and you repeat your recompute stage. What is assignment stage? That is step 2, and repeat your recompute stage is update stage, that is step 3. You repeat step 2 and step 3. What is step 2 and what is step 2? Step 2 is assignment stage. Step 3 is update. You repeat both of them. You repeat both of them with new CJs. At the end of stage 3, you have new CJs because you updated your CJs. Now after this, you go back to step 2. You again assign and then you recompute. You keep doing this until converges. Now the question is, what is convergence? So you keep repeating this loop. You keep repeating step 2 and step 3. What is this? This is not repeated. This is not repeating stage, isn't it? You cannot repeat this. But step 2 and step 3. In step 4, what you have to do? In step 4, you will say whether it is convergent or not. Here you have to check. Whether converges or not. If it is not convergent, again go to step 2 and step 3. Check whether it is convergent or not. If it is not convergent, repeat this. Repeat step 2 and step 3. Repeat step 2, step 3 till it converges. In step 4, you will say whether it is convergent. So what is convergence? Convergence basically means your centroid. Convergence basically means your centroid does not change much. So which means, so at starting stage we have set of centroids C1, C2, Ck. At the end of stage 2, you have new centroids. Let us assume C1, C2, Ck are old centroids and C1 dash, C2 dash, so on, Ck dash are new centroids. Now if you compute C1 dash minus C1, C2 dash minus C2, so on, Ck dash minus Ck, if all of them are very small values, at the update stage, you are updating your centroids. If the centroids did not change much, how do you say they did not change much? If the distance between old centroid and new centroid is very small, did not change much, what does it mean? Distance between new centroid and old centroid is very small. When it is very small, you say that I will stop it, and whatever centroids I have is my final centroids. So at the end of the stage, what do you have? You have your centroids C1, C2, so on, Ck, and the corresponding sets S1, S2, so on, Sk. This is what you have at the end. So you keep repeating this loop. Repeating this loop. At the end of stage 4, we will check whether it is converge or not. How do you check? whether it is converged or not. You look at your old centroids and new centroids. You store your old centroids in a different vector. You also get new centroids. You see the difference. If it is very small, then you will say end it. Very simple algorithm and extremely simple. Literally, you have 4 stages. First stage is initialization, for which you have chosen random initialization. Second stage is called assignment stage, where you are assigning each point to the cluster centroids which is nearest to it. Third stage is update centroids by taking all the points within one cluster and recomputing the centroid as an average point. And fourth stage is you are repeating step 2 and step 3 until convergence. What is convergence? If new centroids and old centroids do not differ much or they do not change much. Very simple algorithm. Actual mathematical formulation problem is very hard problem, also called as NP hard problem. I can say it is NP hard problem, and we know that problems like NP hard in computer science, we do something called approximation algorithms. The approximation algorithm for k-means is called Lloyd's algorithm. Very simple and elegant algorithm. We just have 4 stages. So you have your initialization stage, assignment stage, update stage, and repeat or end stage. Very simple, elegant algorithm. We will see how this works in the real world. What are its drawbacks? How to improve this algorithm? What are its variants? Extra in future classes. Thank you very much.